So I've just been watching a clip of this podcast with Flint Dibble on Danny Jones' podcast. It's a really good podcast. Now this is a topic of ancient civilizations, ancient manufacturing techniques, the pyramids, that kind of genre of things to talk about essentially. And I'm fascinated by it. I find it, to be one of the most interesting things being talked about right now. The origin potentially of where we came from, what technology we've lost, how these things were made. Now, Flint Dibble in this podcast is talking about these ancient Egyptian vases. And if you don't know who Flint Dibble is, he's got a great name, but he also is an archaeologist, and he studies, ancient civilizations. And he's basically an argument against a famous man called Graham Hancock, who has the idea that we have amnesia as a species, and that we've actually lost a lot of our technology due to a giant cataclysm which basically erased civilization as it was. So all these advanced structures around the world, we don't know how they were made. Cultures have adopted them as their own. And yeah, that's kind of the premise of what's going on right now. But in regards to these ancient Egyptian vases, this is the part where, as someone who's worked on a lathe, understands tolerances, understands a bit of engineering and a bit of machining, not to any high standard by any means. I'm not a machinist or engineer, but the design field, and being a designer, you work with tolerances, you understand manufacturing processes, in the area of product design, which is where I actually got my degree. But yeah, we're talking about these vases, and these vases are fascinating. Now, what's fascinating about these is the fact they're made out of some of the hardest materials on the planet. They were supposedly made 5,000 years ago with primitive tools. So yeah, and this is kind of what Flint Dibble is talking about right here. These vases have since been light scanned at an aeronautical fabrication facility or something, where they actually test parts with tolerances, for super high precision uses. So they put these vases through these scanners, and they've actually got results of how accurate they are. And the results are astounding. They are some of the most perfect objects that exist, seemingly. Maybe not exist, I'm sure we do have more perfect objects, but they are so perfect. And we don't know how they were made. We've got loads of theories of how they're made, but we don't. But this is kind of what Flint Dibble has to say about how they were made. So I'll show you this, and then I'll show you a bit more from Matt Beall's podcast, or Matt Bell, sorry if I'm pronouncing that incorrectly. He's just had an amazing podcast talking about one of the best examples he's got, and it's been scanned, and you can see the data coming off of it. But yeah, have a listen to this.
A couple dozen of these things that he purchased, and they're made out of red granite, and they had them measured in light scanners at an big aerospace company. And they found out that they are completely perfectly symmetrical within the deviation is within less than the width of a human hair.
Yeah,
and that's measuring literally in here, the dimension between the opening, the edge here, and then all around the whole thing is so perfectly symmetrical. It would have had to have been made on a CNC machine today.
I disagree with them. Sorry.
Sorry, guys. What part do you disagree with?
I have. Let's.
So straight away, Flint's I disagree with them. And these guys have taken these vases to engineers, aerospace facilities, where they've measured with, I can't remember the name of it. It's like a laser projection. It's one of the most precise ways to measure a component. And the results show that it's one of the most perfect objects. The tolerances are, well, I'll get into that in a bit, but straight away, Flint doesn't agree with it.
That we do know that they had rotating devices like a ceramic wheel around that time. So
around 5000 BC?
Yeah. And in the Near East and in that area, I think around that time, even in Egypt, they had the ceramic wheel. So to assume that they would not use something that rotated around to make a stone vessel is a big assumption, if you see what I mean. I don't think any reason to assume that. We also have tomb paintings that show how these are being made with a drill that you rotate around.
So these are some of the images that Dibble is claiming is how these vases are made. I don't know. let's keep playing.
Facts that were the drill bits themselves, and they reconstructed it on the wood and stuff like that. And so they had a whole section on exactly how these vases were made as the Egyptians themselves described it, if you see what I mean. Now, don't get me wrong, these tomb paintings are later, because at the time that some of these really early ones were made, they weren't painting their tombs. It's just how it was.
Right.
And so, but later on, they show what they do to make stone vases. And there's a YouTube channel, Scientists Against Myths. It's a few Russian scientists who have reconstructed stone vases.
I watched it. It was terrible.
Well, just because
The recreation they made, it took them years.
Well, okay, because
and they did a terrible fucking job. It was awful.
They had one that measures more accurate than the ones that UnchartedX
No, they didn't. I watched the video.
Well, they have several videos. You need to find one of their more recent.
So this is like some mad claim from Flint that these guys actually made one that's more accurate than one of the older examples. So I actually have looked into that video, and yeah, Danny's right, like they're not the same. It's not the same at all. It's completely different, but I'll get into that in a sec, and I'll show you like a few of the things that I'm a bit like, well, you haven't actually recreated, you know, what you were trying to recreate.
Ones where they actually make one where they do the measurements and it's more accurate than the measurements UnchartedX.
Steve, you gotta find it. Because I watched one recently. I don't know which
video it is because they have several videos on this topic. But they definitely have a video where it's more accurate.
It is like not more accurate.
It's missed.
So how were they able to get it so goddamn perfect?
Well, I think it just has to do with the circularity of spinning something. You make a compass and you spin it around, you make a perfect circle.
So this part is crazy. What he just kind of like says, yeah, it's to do with the spinny thing. You just, you know, make a compass, you spin it, you get a perfect circle. But no, you don't actually. It's not a perfect circle. You will get like variations when you look at microns and that, you know, the precision of that circle that say you've drawn with a compass. It's not perfect. You zoom in far enough, it's not perfect. And drawing a circle is completely different from creating a 3D vase out of some of the hardest material on the planet, which isn't just turned in one axis because, well, it is turned. Well, we don't know actually. We you know, we can't be sure how it's made, but it's not just a case of a vase like a cylinder. It's not a cylinder because it's got these little lug bits on either side. So that requires another process because you can't turn those lugs into it because it's not. It's hard to explain actually.
What kind of drill bits did they use, and what kind of?
I think for these they use flint.
And it was all by hand. There was no pallet.
Yeah, it's something that's spun.
You're saying that they did this out of granite by hand, with the naked eye, no measuring.
Think about it like this, Danny.
Within 1/1000th of an inch.
Well, let me explain why. It's just like a compass. You have a compass.
That's another question. Why? Why does it have to be so perfect?
Well, it's just the way they're making it that makes it so perfect, is what I'm trying to explain. When you have something that's rotating around, so you have the drill, and then you have the bit that comes out here. That's at a...
Yeah, he needs to go to a machine shop and watch people use lathes. I'm assuming he hasn't though. He might, but it doesn't sound like it.
Set distance from the center of that, it's the radius of a circle, if you see what I mean. As it spins around, it's just making a perfect circumference. Just like how a compass works. You don't need high tech to do that. It's just the motion of creating it in a circular way that's gonna naturally make it reasonably perfect, if you see what I mean. It's not like they're pounding at it. If you're pounding at it to make it, or you're jamming something in there to go tink, 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 like imagine like using like a pick, right? If you're doing that, making something perfect is gonna be pretty much impossible.
So is that what the Egypt...
How do they open it up on the inside?
Well, you put something in and then you attach it.
You put something in and you attach it. I can't really understand what he's saying, but it's like very ropey as evidence of how these things are made. What he's saying is just complete hypotheticals. So
there's a wooden thing going in and you attach the drill bit on it so that it circles around. If you're making
wood?
The thing you're spinning is wood and flint stone is attached to it.
So there's so they put a
think about it like this.
And they somehow go like that and hollow out the inside of the granite.
Well, they put the lever. Let's go back to those tomb paintings. They show them best. Let's look at the actual ancient Egyptian evidence of how they tell us they made these.
Okay.
Like let's stick with the evidence, guys.
Yeah.
Yeah. So it's something exactly like that.
Yeah, I mean that was the tool.
Well,
in the
how
video.
did they suck so bad at drawing, but they were so good at making?
Oh, they didn't suck at drawing. Remember, these
Come on, compared to this. They can do this, but that's what they're drawing.
Art is not value judgments. But so that's the thing that comes down. You're spinning that around. At the bottom of that are these drill bits that are attached that rotate around. We have some guys, some scientists in Russia who are willing to invest a couple years into making a stone vase in their free time to show that it can be done.
Yeah, but they failed.
No, they did not.
The one I saw, they failed. Steve, you gotta find the consensus.
They have one from a few months ago where they measured it and it's more precise.
So this is the bit that I'm going to show you now. This is the vase he's talking about and the guys that made it. Yeah, it's cool, but you'll see. So this is them making it. I think it took them, yeah, I think at the end they summarize how long it took them to make it. But you can see it's just like, it's nothing like the vessels, the perfect vessels. And yeah, like fair play, they took ages doing it. So this is the part where I'm a bit like, what? So hang on, let me just mute me.
On the 11th of April 2022, the Anthropogonist team visited the Egyptian Hall of the Pushkin State Museum of Fine Arts in Moscow. The museum staff was kind enough to open a display case with 5,000-year-old ancient Egyptian stone vases and allowed us to measure them, including one diorite vase.
So first up, like, they're measuring it with pretty basic tools. These tools don't have like, you'll see on the ruler, the smallest measurement there is a millimeter. So, you know, that's not that precise. That's nothing compared to what the vases were scanned with. This is like so basic.
So we got a unique opportunity to compare ancient vessels with that.
And then like, look at that technique, like this thing, this measurement device is not level. It's clearly at an angle. I don't know.
Being made by Olga.
So these are the measurements of the good vessel, right? And from what I've gathered, it's essentially, yeah, the diameter. So edge to edge of the vase through a certain amount of heights. And they're basically doing it at 90 degrees. So they're doing it on the handle side and they're doing it on the non-handle side essentially. And they've given you the difference here. But just note that they're measuring it in centimeters, which is not accurate at all. Well, it is accurate, but when we're talking about like high precision, this doesn't cut it really. This is not good enough. There is a difference between each measurement. So like theirs also has some deviation, but it is a smaller amount. But when you look at their vase is almost just like a straight shape. This one's more convex. But also it kind of maybe implies, you see they're quite consistent, this variation. It's almost like if this was 1.8 and that's 1 and that's 1.4, there's some kind of consistency there, which, you know, could imply that actually it's supposed to be like that. That's this deviation of, you know, the sides is supposed to be like that. And this one, I mean, this one is closer definitely, but they're basically just measuring, is there external like rotation, is that symmetrical?
As you can see, our unfinished vase is in the horizontal section, closer to the perfect circle with the ancient Egyptian example. Similarly, compare the wall thickness in one of the sections. Here are the details of the museum vase. And here are the data for Olga's vases. Incredible.
So, I mean, even just looking at them, like this is not the same as this. This is different. Look at those handles. Look at that lip. This is like a pretty harder material. It might not be actually, it might be the same size of material. This is finished way better. Look at it's like reflective. This one isn't. This one does look rudimental and handmade. This one doesn't look anywhere near as handmade. And these are just the wall thicknesses up and down the bars. So I think they've just put that device inside and like pinched it to measure the wall thickness. And yeah, there's variation in the wall thickness, which I think, you know, again, could be just part of the design. It doesn't mean it's incorrect. Yeah, if you put a drill bit down the hole and then you measure the wall thicknesses, sorry, if you created a hole with a drill bit and measure the wall thicknesses, it would be the same all the way up because it's just like a parallel line. And you can see that their vessel is way more parallel, way more rectangular, where this one is more, circular shaped. So you're going to have a difference in the wall thickness. So I don't really think this kind of proves anything. You can't say this is more accurate based on this. Yeah, and look, the way it changes in wall thickness is pretty consistent. So it's basically saying the internal thickness isn't the same all the way around, which, yeah, I mean, that doesn't mean much really. Unless that was like what they intended to do, but maybe they need thicker areas to hold more, mass or like more structure. So here down the bottom it's thicker. Well, you can actually see that down the bottom it is thicker, and at the top it's not. But then on their one, they haven't even got down to these lower levels. So these are in progress. So
The data for all these vases, incredible. The upper walls of our vase are actually thinner than those of the museum item.
So yeah, this is the finished vase. Now it's impressive they've done this all by hand and using like primitive tools, but it's just not the same thing. It's just really not. So this is where they show you how long it took them to do it. So it took 790 days, 546 work days. Yeah, so that's the data on it. I mean, it took a long time to create that little vase. 6 bags of sand, 7 kilos of tar, 2 halves of cowhide. I mean, it's taken a lot of material just to make that vase. And at the end here, they got a 3D kind of scan. Now, if you've seen the other 3D scans, the ones of the real vases, they're way more precise than this. These are some of the other examples. Like this one here is clearly like so wonky. It's not even close to what was made. Sorry, what exists. Yeah, so now I'm going to show you the real vases.
Show you guys and get your initial take on it and your initial impression, first. So this one, I did do a little bit of a video on this, like a little short on this one, and this one is within the X and Y axis of the lip. Are within.
This is insane.
It's 15 1/millionths of an inch. The difference between the X and Y axis of the lip, 15 1/millionths.
So, whereas the measurements of that one that was handmade by the Russian people, they were measuring in they were actually measuring in centimeters. So they were saying like 2.4 centimeters. So this lip varies by 4/10,000th of a millimeter. So essentially, one of those smaller measurements, you cut that into 10,000 pieces. This is 4/1000ths. So this is like, the measurements they're taking are just completely different to the other ones. These are so much more precise, like infinitely more precise. And then you've got 15 1/millionth of an inch. I don't really work in inches, so I don't really understand inches very well. So yeah, I mean, I'll just let them carry on. You can just hear how precise this thing is. And if you look at it, you're just like, wow, what is that?
Wow. So it's like 4/10,000ths of a millimeter.
I mean, yeah, there's a couple things that jump out to me immediately on this. I mean, it's a unique shape. I mean, it's like a flattened version of the oblate shape that we see. It looks and feels incredibly smooth, and I'm sure it is extremely precise, but get this
the depth of
the
the lip,
the cut underneath this lip, like that's trying to machine this out, like and I'm sure with the scan, and you said it's super accurate. I'm trying to look at it. I mean, it's a tiniest of radiuses that's been machined, and this isn't a separate piece. I mean, I can feel. I mean, it's not some people think that these are like collars that go into it. It's not. This is the same thing, like that. That's incredible. Like just this bit alone, like trying to show this to a machinist and explain how you do this, how you cut this angle on it. Russ, check that out. You got to see it. That is.
Bearing in mind, like Matt Beall, this guy, he's bought a load of these from like private collections and auctions. So you can see he is. I don't know how many he's got. He's got maybe like 50. Some of them are less perfect. He's admitted that, but a lot of them are so perfect. And I think he gets into the data in a second.
Sits perfectly flat,
Yeah,
of
my
course.
God. This is such a privilege, people.
Spin for years. It'll.
I imagine it would.
Yeah, I mean,
Okay, and it's very deep this way.
Yeah, it's
Right.
It's
Right,
thin.
so it's not like there's just a little hollow in here. They made a thin wall all the way around.
Oh, here we
there
go.
you go.
yeah.
There's the
Oh
report.
man,
Yeah.
yeah, we definitely want to talk about this.
Yeah, look at that.
And
look at the
it's
profile.
light. You can see how it's been machined underneath because it's light. Like it doesn't. There's
Yeah.
not a lot of mass to it. It's
Yeah, so this is the measured variance is it's 126.718 millimeters on both the x and the y axis. So you have to go out to the 10,000th. You have to go out 4 spaces past the.
This is just like insanely precise. 4/10,000th of a mil. That's the variation. So they measured here to here. So hang on, is that the x or the y? That's the y. So they get this measurement, 126.7179 mil. So like the last measurements they were actually doing, so that would have been 12.6 in the previous video. That measurement would have been 12.6. That's as accurate as they could go. So yeah, so the difference between these two is 4/10,000ths of a millimeter. So that is so small.
the same. I mean, it's the same. It's the same. Okay, so 0.4 microns.
Yeah.
Holy crap! All right,
Yeah, dude.
so it's less than a micron difference.
Right.
Oh,
less
my
than
Lord.
less than a half of a micron. So clearly, a lathe was used to manufacture this. Right. I mean, look at those freaking lines.
Yeah, you can see it.
Yeah.
Obviously, it's a perfect circle. It's got the lines going in circular all around it. This was turned. I mean, there's no question about that.
Yeah, and this is in.
So this is like showing the variation in the surface. So where it's red, it's like slightly higher. So when he's saying this has clearly been turned on a lathe, you can basically see the bands of where potentially material has been removed, and the fact that it's consistent would suggest that maybe the tool is in the same position as it's been removed. So this scale on the right is so saying 0.500 to minus 500. So there's low and high areas on the surface, but this is in, I don't know what measurement that is in actually.
Scales in millimeters, I assume. 0.
Correct.
Oh, so it's in millimeters. So this is 1/10 of a millimeter. That digit there on my mouse is, that would be a millimeter.
Dude. Yeah, this one has. I believe so. I think we talked about it,
But the other thing I was going to say
crap,
earlier,
dude.
like anyone who's worked with vector style graphics or, CAD stuff and you have a design is familiar with how you can sort of grab the whole thing and just squish it, It's
Yeah.
like, and that's what this reminded me of. It's like,
This
it's
other
one
one?
of these, but they've just sort of flattened.
So that's kind of like my thoughts on the vase topic. I think, UnchartedX, Beall, this guy's from Brothers of the Serpents, I believe. They're all doing good work to try and, figure out what was going on back then. And I think Flint Dibble, like, I don't know why he's so reluctant to, look into this further and look at it from an engineering point of view. Take out like civilization out of it, just look at it from engineering, like how it's made. I know he referenced those other people that did make a vase, but it took them a year and it's not as precise. It's just, there's no way. Yeah, these things are made, there's so many of them. They're like the hardest stones. Yeah, it's fascinating. It's a fascinating topic. But yeah, I might make some more videos on this if you guys are interested. Let me know. I might do some CAD work on them, see if I can recreate them in SketchUp or 3D. And yeah, other than that, have a good day wherever you are.